Good afternoon, everyone. Thank you for joining this session on advanced scripting with the ArcGIS API for Python. My name is Rohit Singh, and with me is Atma Mani. We are from the development team. We developed this API. And this is, what is this API? It's, you might have heard of ArcGIS. ArcGIS is a Python API to desktop GIS. This is the Python API to your Web GIS. It's a Python library that you use for spatial analysis, mapping and administering and managing your Web GIS. It's powerful. It has all the capabilities to administer your GIS, the content, manage the content, and all the analytical capabilities in your GIS. It is a new API built for Python 3. It works very well with contemporary Python libraries, works very well with contemporary frameworks like Jupyter Notebook. And we worked hard, so it's easy for you to use. I hope you find that. It's as an implementation detail, it's powered by the REST API. Under the hood, it talks to the Web GIS primarily through the REST API, and we are adding more local capabilities to it, including the spatial data frame. So some more local capabilities are coming. And the two key areas where you'll find it useful is for automation and for data science. You might want to do automation. We'll see some examples of that. If you're who did we build it for? If you're an administrator or a DevOps person, you want to set up your Web GIS, create users, manage their roles, manage groups. If you want to manage the content, you might be a content publisher. You want to publish content as layers, publish web maps, fix broken links, fix the items, update features. You can do content management with this API. Most of the analytical capabilities in the Web GIS are available through this API. You could automate your repetitive analysis with this API. And if you're a data scientist, you're not looking into automation, but just getting the insights into your data, deriving insights from your data using the best tools possible. You might be using pandas, you might be using other Python libraries. You could use this as typically data scientists use code to derive insight. You could use it like that. If you are a GIS user who's not very familiar with Python, this is a great API. It could be the first API with which you start programming, because Python is so easy to learn. It's a great stepping stone to start scripting your workflows. And if you're a Python developer who's not very familiar with GIS, to that Python developer, it's a great introduction to a GIS. So you bring your GIS in your Python workflows. This is an API overview, a module diagram of this API. You always start with the GIS module in the light green color here. That's the entry point, and you use the GIS module and its sub-modules to manage your GIS. There are also sub-modules to administer and manage the servers in your GIS. And the modules in green, like raster and feature, these are modules that work with spatial data of a particular kind. And in addition to the types or the classes representing that spatial data format, you also have the tools that work with, or the functions, the geoprocessing tools that work with that kind of spatial data. In green are modules that you use for certain workflows that you may have. And this API also has support for visualization, both for editing and creating web maps and web scenes in the mapping module. And if you're using Jupyter Notebook as an analyst or a data scientist, we provide you a widget, and that's also available. So we'll do like a quick tour of this API, and we'll try to go into some important areas. We'll start with the GIS module. That's the entry point into the API. And this is a module diagram of the GIS module. The most important class, the class that you start with, is the GIS class. This class represents your Web GIS. It could represent ArcGIS Online or ArcGIS Enterprise. And we've got a very simple model in which this class has a handful of helper properties, like content, users, and groups. And these properties let you get to the content, that is, create, get, or search items, groups, or users. So they all follow the same pattern, and these are implemented using the corresponding manager classes. And for each resource, which is items, groups, or users, you've got properties that you can use, and there are methods that work with that type. So you'll find that it's a similar pattern that works. So let's have a quick look at the GIS module in this notebook here. Let me go to full screen. I'm importing the ArcGIS, the GIS class from the ArcGIS module, and the way you connect the first line of code would be that you connect to your GIS. So I'm connecting and calling the GIS constructor. The constructor lets me pass in the URL to my GIS and my login credentials, which could be username or password. And if you're using other authentication schemes, you need to pass other things. If you don't pass in a URL, you're connecting to ArcGIS Online. That's your default GIS. And if you don't pass in a username and password, you are connecting as an anonymous user. So I'm connecting, in the first case, to ArcGIS Online as an anonymous user. Administrators could configure anonymous access for their GIS. In the second case, I'm connecting to an ArcGIS Online organization, giving it my username and password. Now, we also realize that you don't want to put your passwords in the code, so you can create a profile like this and give it a name. And once you connect with that profile, it puts it on your disk, and from that point on, you can just give the profile name, and it uses Windows or whatever OS secure store you have to store your passwords. So here I'm also connecting to this other organization that I had here. I had created a profile, so I was able to connect like this. And here I'm connecting to an enterprise, so that represents my GIS. Let's see how you work with users, groups, and content. I'm saying GIS dot, and if I hit tab, I get IntelliSense. These are the properties that I was mentioning. So I've got a property to manage my content, manage my groups, create a map in the notebook, get properties or update properties of the GIS, and manage the users in my GIS, depending on if I have the privileges. So if I'm logged in as an administrator, I'll also be able to create users, for instance. But if I'm don't have those privileges, certain functions will not work, or you won't get certain properties. So it's a dynamic API. So gis.content.me tells about me, and here I'm getting a particular user in the user object, gis.users.get, and this object lets me access its properties. So I get the first name or last name. These are the properties, and the object is also a dictionary, so I can use dictionary notation to get to them. So that's something we picked from pandas that makes it easy in certain cases. This is also showing you can use attribute access to get to those. Here I'm searching for all the users in my organization, getting a list, and picking the first user. And then on the user, then I get methods that that help me. I get the properties of the user as well as methods, so I can query the items that this user has. So here I'm listing out all the items. One of the integrations that we've done with the notebook is that it allows for a richer representation. So I could call the display method that gives you the results in a format that looks like the search results from ArcGIS Online. Same pattern with groups. So Python fits in my brain. That's one of the Zen of Python things. So try to use the same patterns throughout the API. gis.groups, I'm searching for a group, getting that's the groups. The first group, that's the LA County Emergency Management Group. And group also has content, so I'm displaying content. Groups are a way to collaborate. You can add members to a group, and you can share content to a group. So all those members of that group are able to work on that content. Coming to the content, I can search my GIS for content. I'm searching for all items that match with Chennai and displaying them. I get a CSV file here. I get a feature layer. I could also specify, filter it by the type of item that I want. So let's say if I only wanted feature layers, I made a typo, feature. So one of the nice things about the notebook is you can go back, fix a cell, rerun it. So yeah, now I only get the feature layer. So, and then if you wanted to search outside of your organization, there's a way to do that as well. Now I got the first item. I can get its properties like the owner or the snippet. I could update these properties. That's showing how you could update them. And also there are like a lot of people come like, I want to know about item relationships or item dependencies. Does this web map, which layers does it depend on, or which layers is it related to? So there are helper methods like to get that item relationship. Now you can also administer the servers in your GIS if you. So when I logged into my enterprise, I logged in with administrator privileges. So my GIS object also shows the admin helper object that lets me get to the servers. Once I have the servers, I can filter them by their function or their role. It has a GeoAnalytics server, and this is getting the hosting server. I can get the server services. This server only has one service, and this is showing how you can query the properties of that service. And the status, the statistics, and you can start and stop services. So that's also available for you. So that was the GIS module. Now we'll switch over to Atma. He's going to show us the features module. So we covered this module. Now let's switch over to you.
Thank you. So first of all, thank you all for staying back on the last day and making our session a great success. Go Python. Well, yeah, we could wait for that till the end. So.
That's for them. For staying.
I'm so sorry, I thought he was clapping for me. Just getting a little ahead of myself. So let's start with this module diagram. So this is the most important part you got to understand if you want to understand about the features module. So let's start here. This is the object that is most important, a feature layer collection. All the feature services that you know in ArcGIS ecosystem is represented as a feature layer collection in Python API, because a feature service, as you know, has a number of layers, hence the name feature layer collection. So when you query the layers property on a feature layer collection, as you expect, you get a list of feature layer objects. Similarly, you query the tables property on a feature layer collection object, and you get a list of table objects. And then, how do you go further from there? You do the query method on a feature layer, specify a SQL query, or with numerous other parameters. We're going to look at the different ways of doing queries in the demo right after this. You get a feature set object. A feature set, as the name indicates, is a collection of feature objects. So a feature set has a features property, which lets you, gives you a list, Python list of feature objects. A feature object is the atomic entity in your GIS, right? It has two things. One, it has geometry that specifies where it is on the Earth, and it has attributes that specify all the non-spatial data about that particular feature, like name, location, significance, population, number of crime, number of accidents, or anything like that. So going back in reverse, feature is an atomic entity in your Python API to represent a feature in GIS. A collection of those features make a feature set. A feature set is obtained by querying your feature layer. And a feature layer is one of the n number of layers that can be in your feature service, which is represented as a feature layer collection, right? In addition to this, you have feature collections. These are really lightweight equivalent of feature layer collection. These are not powered by services. If you used the map viewer and you clicked on and said add map nodes, it lets you sketch on the map viewer. Any of you done that? A few of you have done that, cool. So those are really lightweight, and those are really JSON objects. You cannot have too many of these because for size constraints. And those are feature collections, and you can actually save those as feature collection items in your GIS, and that object, points to those feature collection objects. And then you have feature analysis tools. We wouldn't be getting quite into these in today's visit to the feature module. The other talks that dealt in depth on these tools were the mapping analysis visualization, and the data science topic by Rohit and Andrew earlier. So this is the overview of the features module. So now let's get into a few demos. Let's start with importing the Python API. I'm connecting to my GIS. Let's do a search for Fortune 500 layers, Fortune 500 companies in the US. And here is my item. This item, if you notice, is a feature layer collection item. Let's see how we can go from there. You can query the URL property and you get a feature server endpoint that you're quite familiar with. Let's import the feature layer collection object, and we can create a feature layer collection object by specifying the URL in your GIS connection. Then you can call the layers property on that, and you get a Python list of feature layers. It's just synonymous to what we saw here. Feature layer collection, call the layers property, you got feature layer objects. Let's get back here. And then let's drill a little bit deeper into that. I'm working with the 0th layer in my feature layer collection. Now I can go ahead and query the properties of those feature layers and get their names. I can get numerous of the properties, like what all fields are there, what all data types of fields are there, and such kind of things. So let's start to work with the cities over 1 million feature layer in this a list of feature layers. I can query the extent, try to see that, but we can do better. We can draw a map and we can add it and see how that looks like on a map. Okay. Go ahead and draw it and then turn the base map so we can see that a little bit better. There we go. These are our features in that feature layer. Now, I told you that we can run query method on a feature layer and you get back a feature set. So I can go ahead and do that. While we are at it, Jupyter Notebook, you can do a shift tab on a method and get its signature. So you can expand this one. You can see that you can really get really finite. You can really specify the kind of query you want. You can write a SQL query in the where clause. You can specify what all the fields you need. Something that I do often is if you want to find the number of features in that particular feature layer, instead of querying and getting everything, I can just get the count of that. So there's somewhere hidden here is return counts. You can do out statistics if you want the server to summarize and send it back to you. I control the out fields if I'm only interested in a particular fields. If I'm not at all interested in geometry, I say return geometry equals false if only you need attribute column. So like this, you can optimize what you're querying back and you can reduce the traffic, amount of data that's returned back. And Python API will do the paging for you. So if your server has a really limited max record count, Python API will do the paging. And if you say the max record count for your server is 1,000 features, and your query result resulted in 5,000 features, we'll get that sequentially and return you back. So you don't have to worry about that. So we can query the geometry type, and as you see, it's a point. You can get the spatial reference. This is one of the most powerful features in the Python API. Is I have a feature set object. I'm calling the df property on that, which gives you back a pandas data frame, with which over here we just saw the spatial representation of that feature layer. Now we are able to see the attribute, non-spatial representation of that feature layer. So you can go take a look at what all the different columns are there, what values are there, and so on. Similar to in ArcMap, where you'd have a map on the top and you have attribute view on the bottom. Similar to that in the Jupyter Notebooks. If you call the query, if you find the type of that df object, it's a spatial data frame object. It's where Python API, we have enhanced the data frame with spatial abilities, and we give it a new type called spatial data frame, and that's what you're seeing it here. Now we have come up to this point. We started with a feature layer collection, called the layers property. We got a feature layer, ran a query, pretty simple query, and then we got a feature set. Now we're going to call the features property, and we're going to work with feature objects. And I'm going to show you how we can edit features while we are at this level. So I'm calling the features property on a feature set. I just got back a list of features. You can find the length. It will be somewhere, around 8. This one starts from the 0, so it's number 8 features. You can get the 0th feature. You can look at the fields. If you want to know the type of those fields, you need to go to a higher level container, which is a feature layer, and then you call properties on that feature layer and call for fields. You'll be able to find the data type of those fields in addition to what those fields are, what the aliases are, etc. We can look at the attributes of one of those features. You get the name, you get the population, etc. Now let's take a look at editing features. If you want to edit your features on a feature service, you need to have editing capability. But like you saw here, I don't have that on my feature service. But luckily, I am the person who published it, so I have the capability to change what capabilities are on the feature layer. And we can do that with Python API. So let's take a look at that. What you need to do is you need to update the definition of your feature service. And you can do that by, I am at the very high top level container. This is my feature layer collection. We go all the way to the top, to your feature service, and that's where you define your capabilities, so what all users can do. So you need to go back to the very first feature layer collection object that we created, access the manager object under that, and call the update definition and send it the capabilities that you want to apply. Let's go ahead and run this. It gives you back success if I have the permissions. If somebody else does it and the person doesn't have permissions, it's going to give them back a failure message with appropriate information saying that, hey, you don't have permissions to do that or such and such. Now we can go ahead and query the capabilities. Now it returns me create all the crude capabilities, I guess, against to what it returned earlier, which was just a query. Now, let's take a look at this. This is Fortune 500 companies, cities with Fortune 500, cities over 1 million in population. And New York here is confusing me because I don't know if it's a state or a city. So I want to change it to New York City. So let's see how you can use Python API to edit a feature. You can edit the geometry. In this case, I'm keeping it simple and just editing an attribute value. So I'm searching for my features and finding that New York feature. Once I got it, I make a copy of it and change the value that I want to change. So this is my feature that is just changed. As you see, the name now represents New York City, and earlier it was just New York. Well, this was Los Angeles, but yeah, earlier it was just New York, now it is New York City. Now to edit my feature on my feature layer, I call my edit features method, and because I want to update, I'm passing the updates parameter. I'm passing a list of features that I want to update. So I can run this, and you'll notice the result back says add results is empty because I'm not adding anything new. I'm not working with attachments, so that is empty. I'm not deleting or dropping a record, so that's empty. I updated just one, so what I get back is one list of one dictionary that shows what I updated. So I can go back to my query up here, rerun the query, and you will notice the new result. You can go back here, and New York would have changed to New York City. So just like that, this is persisted back on the feature service. So any other client that is using the feature service will get the updated results back. So that was a quick tour of features module. We looked at the various objects. We'll drill down all the way down to a feature, and we made an edit and pushed it back to the service. That was a preview of the features module. But it gives you an idea of what all you can do with the Python API in a scripting endpoint, right? So let me shift it back to Rohit.
Yeah, so features are quite powerful. You can update features, you can add features, you can delete features. That's a very common thing that you want to do. Now, we've been using the Jupyter Notebook to show the demo, but the Python API works wherever Python runs. It could run in a command line, it could run in your Python IDE, it runs within the Python window in ArcGIS Pro, and it works in Jupyter Notebook, which is this Python IDE. Now, that's great for documenting and presenting your work. It also has a great community of extensions. So I'm using one of these extensions to turn this into a notebook, my slideshow into a notebook. So looking at, or rather my notebook into a slideshow, sorry. So We'll look at imagery and raster analysis. It works similar to features in the sense that, I'm searching my GIS. At this time, I'm searching for the Landsat layer, and I've told that it should be of type imagery layer. So I get the first item. On that item, we've got layers. So similar to the feature layer collection item having layers, this also has layers. In the case of imagery layer, you only get one layer. Now, we've done some, so here it's querying some properties of that item, getting its description. It has different bands. We are seeing that. One of the integrations that we've done with the Jupyter Notebook is that when you query an imagery layer in the notebook, you get a visual representation of that in line and in real time, so that imagery layer is rendered within the notebook. Here I'm getting some properties of the Landsat layer. We know that it has different bands and their wavelength ranges. So here I've added that layer to my map, and these layers, imagery layers, can be published with raster functions on the server. In this block of code, I'm cycling through all the raster functions that this layer has been published with, printing the name of this function down here, applying that function to that layer and adding it to the map. So we are seeing the visualization of the layer changing based on which raster processing is happening on it. We saw the color infrared. This is NDVI colorized. You can do a lot of raster processing, but this is happening on the fly and using the raster functions that have been published with the service. You're not restricted to using just the raster functions that the server provides you. We give you over 200 raster functions that you can use. Here I'm applying a particular raster function that's been published with the service, but we'll also see how you could use other raster functions. This is when you're working with an imagery layer, you're not working on the whole extent. You have an area of interest, so you can set that extent, and then you'll start working with that extent. So I'm getting the color infrared for redlands, which I got by geocoding this. You could export those imagery layers to a byte array or on disk. That can be useful if you want to use OpenCV or other Python libraries to do image processing on those exported images. I use that in one of the samples to identify the circular farms that use center pivot irrigation in Saudi Arabia. That's one of our samples. This is showing some of the raster functions that are available to you. So from the ArcGIS raster functions module, I'm using the extract band function to extract the 1, 2, and 3. That is the RGB bands. And then I'm stretching that image. That gives me a natural color image. So this is what it might actually look like from the satellite. Here I'm clipping to an area of interest. So I got the geometry of redlands, and I'm clipping to it. So the way we get the geometry of redlands is also, you can have a sneak preview of Geo Enrichment. I can get areas by name. So I can say within the United States, the state of California, get zip code 92373. So I'm getting not really redlands, but that zip code's geometry. I've clipped it. When I query it and add it to a map, then that raster is clipped to that location and added to the map. Now Landsat has been collecting these scenes over so many years, and from that Landsat collection, I can filter the rasters that I want or the scenes that I want. I could filter them by a where clause, wherein I could specify things like the cloud cover should be less than 10%. I can say only get those scenes that intersect with my area of interest, and I could also filter by time, starting from this date to that date. So I got my filtered scenes. I'm getting that as a data frame here and visualizing it here. So we get the acquisition date, the cloud cover. And we've got like 60 scenes for Redlands, since it was it started collecting the Landsat scenes. So once I've selected a bunch of scenes that are overlapping, 60 scenes that I just selected. How do you resolve the overlap between them? You need to do some compositing. For that, we've got mosaicing methods, and we've got helper methods like getting the last scene or the first scene. So here I've added the last scene. Here I've added the first scene from Landsat. So that will be useful when you're doing analysis like change detection, or you want to get the mean. So these helper methods are available. There's a quick example of doing change detection. I have an old scene and a new scene, and I want to see how much vegetation has changed. Has it increased or has it decreased? And I'm creating this difference image. It tells me in green are the areas where vegetation has increased, and in magenta are the areas where vegetation has decreased. How do I get that? Every image has R, G, and B. So if red, green, and blue are same, it would be a grayscale image. If they are all 0, it will be black. If they're all 255, it will be white. If it's somewhere in between, it's gray. Now, for the green band, I'm taking the new image, getting its vegetation index. So the vegetation of the new, if it's more than the vegetation of the old, then green will be more, and we'll get a green shaded image. That's the logic behind how it works. And red and blue mixed to combined add up to magenta. If the vegetation was more earlier, then the magenta will be more. So that's the logic behind why you get that.
Can you scroll the right real quick?
Sure, or I could do this and you'll see everything. So yeah. You could also apply a threshold mask. And this is another way of doing it. So earlier I was doing the difference image. I could also use map algebra. So I could just subtract the old vegetation from the new vegetation. This is map algebra. Now it works with your Web GIS. And that's the difference in vegetation on a scale from 0 to 1. And I could set a threshold that only tell me where vegetation has increased by 0.1. And those are the pixels that I'm interested in. That's what this block of code is doing. And I get those results. These are the places where vegetation was more than 1. And finally, I can visualize it all on a map here. So that was imagery and raster analysis. One quick thing about, one more important thing is that so far it's been doing this on the fly at the display resolution. But when you do raster, and you can get these results very quickly because it's on the fly and it's only at the display resolution. But you then want to do this analysis, this processing at the source resolution across the extent of your area of interest. And for that, you'll want to do this processing on ArcGIS Enterprise, leverage the power of image server and distribute this analysis to the image server. Now that sounds complicated, but all you need to do is just call save on the result that you got, the result of your raster analysis. If you call save on it, it'll transmit that raster processing to ArcGIS Enterprise. It'll generate a raster and applying that raster processing chain across the extent of your raster. And if you call two features, then it'll do a raster to feature conversion and it'll create a feature layer. This will create a raster layer, or rather an imagery layer. So that was imagery and raster analysis. Now we'll switch back to Atma and we'll go to the next module.
Thank you, Rohit. So, like a Python, we just slithered from GIS to features module, and then we moved from features to raster, and now we have moved back into geocoding. So in the next 6 minutes, let's see how we can turn addresses into X and Y using the geocoding module, and how we can accomplish with just a few lines of code with Python API. So we start with, this is the point that you need to make a note of. From our GIS module, we are importing the geocoding. Is this still visible in the last row? Should I increase the font size at all? It's good? Okay, cool. So yes, we are importing the geocoding module, connecting to my GIS. And with this, what all can you do? You can geocode single line addresses, which is something like 123 Main Street, city name, state name. Multi-field addresses is when you can break down the address into subcomponents. Like you know what the street name is, you know what the house number is, you know what this sub-region or the county name is, etc. Points of interest, like Eiffel Tower, San Diego, or Palm Springs Convention Center is a point of interest. Administrative place name would be County of Riverside, County of Santa Barbara, something like that. Postal code is just zip codes. You could feed in all of these and to a single one method called Geocode, and to turn all of that into X and Y for you. So let's start with that. Now let's expand this. So I'm geocoding a place name, Palm Springs. And the first time I did it, I was very surprised. Look at this. The results I'm getting back is huge. It's enormous. I was expecting just I will get an X and Y. But what I got back, let's see, look at this. The length of that is 20. Because by default, the return results is max locations is 20. But you can change that to any number. And the geocoding server tries to find as many matching connections, as many matches for this string that we just geocoded, and gives you back a list of dictionaries. So let's see how we can make sense of what we got back. I can take a look at one of those results, and you see it's a huge dictionary. The address was what it tried to geocode against, and then it gives you all the details, X and Y, display location, city name, address type is a locality, language that it used is English, what geocoder name is world geocoder, and so on. It gives you so many different things. It gives you a rank, it gives you a score. Score is something that you need to pay attention to. It's the confidence that the geocoder has for geocoding that input to a location it gave you back. So 100 is the max confidence it can have. The subregion points to the county under which it falls, and then you get your geometries back. So we can create a map, and we can draw the result that we got back. Yes. Okay. And then we just geocoded Palm Springs in the center of the city. Palm Springs Convention Center would be a single line address. What we could do is we could try and see of the 6 different results it geocoded against, what are those names that it tried, and what is the score for each of those. Palm Springs Convention Center by itself had a 100% hit. It made a small change. We cannot quite tell it from here, but if you just change it a little bit, it might try Palm Springs or Palm Spring Convention Center. It might try to tweak your input a little bit and try and geocode. It tried against Hot Spring Convention Center and Alice Springs and various different variations of that. So you can make typos. Well, the point I'm trying to say is your input can be dirty. It doesn't have to be clean. So it has fuzzy logic built into it. So it'll try to make best sense of what your inputs are. It can have typos in it, and it'll try to give you still the best result. As long as you pick the highest score, you're getting the best result you can for that particular result. Multi-field addresses is something similar where you just break down your address into address, cities, region, subregion, etc. And you can still send the same thing to the geocode method, and it'll try to give you geocoded results back. You could do many more things with geocoding. We're just scratching the surface of something here. What we could do is you can try to geocode results within an extent. So I need, within 5 miles of my house, get me all the grocery stores, get me all the hospitals, something like that. And that was how I shortlisted the house that I wanted to buy, is running all these geocoding conditions and trying to find the best place to buy a house. So something here is we can try to get the extent of Palm Springs Convention Center and try to find the restaurants within a walking distance of that. So you could say geocode, say restaurants, search extent is the convention center's extent, give me at least 15 restaurants I can choose from, and we get back just 6. What we could do is we could loop through each of these and draw them on a map, and you see these. A few different restaurants that just got rendered on the map. You can click on one of these and see what the result. It's a Sherman's Deli. I thought of going there for breakfast. A few different places like this. So this is an example. You can just change this into grocery store. Let's make it grocery. And let's find out. We didn't get back anything. Hospitals. Oh, yeah, there are no other results in this vicinity. But you could change this to something else and you would start finding results. So that was searching within an extent. That's what I showed you. Let's switch gears and see how we can, this is practically when you're scripting, you may be encountering a situation like this, where you have a list of addresses that you want to turn into X and Y. So here's a list of addresses, a Python list of strings. You could use the batch geocode method. So far, we have been using the geocode method. Right now, I'm using batch geocode, as the name indicates. We can do a batch geocoding of the results. I gave 6 different inputs, and Geocoder was able to successfully geocode all 6 of them in my results pack. So you can create another map, loop through them, and I can draw them. So we just saw. Okay, let's do that one more time. And draw this. Okay. All the 6 were geocoded onto my map. Here is an interesting thing, is reverse geocoding. Cases where you have X and Y, but you want to find out what is that place. You right-click on a map and try to find out what's going on here. Cases are maybe you have AVLs and you're collecting logging information from all those vehicles, and all of a sudden one of those points seem to be outliers. They seem to be a mistake, and you want to find out what's going on there. The workflow would be maybe you're opening up ArcGIS Pro or Web Map Viewer, throwing your shapefile or CSV file, trying to find what that layer is, and then you look at the base map and try to find, oh, that was a gas station. Okay, makes sense. That was a rest stop. Okay, makes sense. That's why the driver stopped there. Well, same kind of questions you can answer with reverse geocoding. You just have an location like this, X and Y, and then you can do a reverse geocode and it turns out to be Eiffel Tower, X and Y. So that was a simple example of how you can turn. And by the way, projections and coordinate systems is deep into ArcGIS in all the places. So whenever you call geocode, you can as well say, hey, give me this spatial reference, and geocoder will give you back in that spatial reference. You give an input in I gave lats and long because it's easy to understand. You can give whatever spatial reference you're working with, it will understand and work with that. WKID is a format in which you specify that spatial reference. So for teaching people, getting kids interested in GIS, you can do a small fun activity like this. I just threw a map. And these maps, this map object, has a click handler. So whenever you click on it, you can tell it to do some action. So here, what we're going to do is, whenever you click on it, I'm going to ask it to reverse geocode that point and give an address. So I can click here, and I'm going to get Palm Springs Convention Center. Click somewhere here, you get an address. Click here, you get an address. Let's give it a hard time. Let's click on the mountain. So Palm Springs, they make it even harder. Yeah. So yeah, cool. So that was a really quick tour of geocoding and how you can turn addresses into X and Y and do the reverse of that. So let's switch gears here. I'm going to give it back to Rohit.
Okay. Thank you, Atma. So on the topic of geocoding, one of the new things that we added is that if you've got a list of addresses, which could be on a layer or table of some sorts, that's an item in your GIS, you can geocode that list of items as well. And if you've got a huge number of addresses to geocode, GeoAnalytics recently added a capability to geocode a huge number of addresses that are in a big data file share. So just for completeness. So the slithering Python has now covered GIS features, raster, and geocoding. I wanted to give you a quick tour of the website, which has our guide, it has samples, and it has the API reference and the GeoNet community that you could visit. I just quickly wanted to show you the API reference, and you'd notice that in the features module, it has the types for working with features, and it also has the geoprocessing tools for working with features. And the same goes for raster analysis. That had the raster functions actually. For network analysis, you'd find the same pattern, the types, and the network, the geoprocessing functions that work with network analysis. So the next topic we want to cover is geoprocessing. Now, if geoprocessing is built into the API, why do we need a separate geoprocessing module? Well, that's to call geoprocessing tools that others might have published, or you might have published. You can call those as well. And I'm connecting to my GIS, and now I'm searching for geoprocessing toolboxes that others have shared on the GIS. I get back a few results. I'll be working with this second result, the ocean currents, and that's I get that in this object. And just it's a very Pythonic interface. Just as Python has an import statement, we give you an import toolbox method in the geoprocessing module, and you import toolbox, and you get like a module. And on that module, there are the methods that work with that module. So the ocean currents module has it had the message in the bottle which this tool supports. That's a method. And when you query its help, you also get that within the notebook. So we know that this method takes in these inputs and it returns this output. Then you can call that method. So in short, search your GIS for geoprocessing toolbox, import it, you get a module with a method, one or more methods that are in that toolbox, and you can just call it like a Python function. Let's look at an example of that. Here, I'm not going by the item, but someone has published a geoprocessing tool as a service. I can go by its URL, import it. I get the Viewshed module. On the Viewshed module, if I use IntelliSense, let's insert a new cell here. Viewshed dot, and I can use IntelliSense. I'll know what functions are available. I can do question mark and get its help. So Viewshed takes a click point, a point from where it calculates how far can I see in all directions. It takes a distance. And it returns a feature set. So let's quickly have a look at that. I have a map here. Created a map here of South San Francisco. And I want to click on this mountain here and see how far I can see in 5 miles from that point. On the map, we can add a click handler. When someone clicks on the map, get viewshed will be called. That's a Python function that I've defined here. It will be called with the map and the click geometry. I'll first draw the click point on the map. Then I'll take that geometry, that's a point. I'll create a feature from that point, and I'll create a feature set from that feature, because this tool takes in a feature set. And I'll say, and the distance should be 5 miles. And it will compute the viewshed, give it a result, which is a feature set. I'll draw that on my map. So let's try that out. So I clicked at a location. You see that this circle got filled. So it's calling out to that tool here, that geoprocessing service. It got back our results, and I've drawn them on the map. So that was showing geoprocessing in action, a quick example. Let's switch back to Atma and see what he's got for us.
Thank you, Rohit. So I want to show you network module, but before we get there, let's do thanks. I want to show you network module, but before we do that, let's do a real quick pit stop at the mapping module. I want to show you something really that applies to whatever we saw before and what you're going to see in the next few minutes after that. So here I have a map, and I have a few web layers. I have the time zones. I have I use histories with some rendering and symbology in it. What I want to show you is something that on this map object you can call layers, and it gives you back a list of all the layers that you just added to it. So if you want to remove a layer, just call the remove layers method and pass whichever layer that you want to be removed. So for here, I can remove the freebase layer, and it is gone from my map. In addition to adding layers, you can draw graphics on it. So here I can call in draw graphics, draw rectangle. So you can go ahead and I can, oops, oh yeah. Okay, I drew a tiny rectangle. Let me do that one more time. Let's draw a rectangle, and you can draw a rectangle here. And you can, there are a whole bunch of this. If you look at the documentation for draw, you'll find various different shapes, sketches that you can draw. All these go into as a feature collection when you save the map. If you want to clear those graphics, you can say clear graphics, and it goes away from your map. So let's do this next thing, which is the ability to save a map. Just create a dictionary with item properties, snippet, title, tags that you want to be once you save this web map, and simply call save method on the map object. Pass the item properties, give it a thumbnail, folder wherever you want to save, and the Python API will go ahead and save the map that you used as a web map on your GIS. So you can right-click this, open it to. This is a standard web map that any other application like ArcGIS Pro or Collector or any other application will be able to make use of. Yes. Yeah, the same map. We could have added as many layers as we want, raster functions, imagery layers, and those things would show up. So that was a real quick thing that I just wanted to show you. Now let's take, yeah, this world time zones layer that I just threw into. Okay. So let's take a look at the network module. So this the module that helps you make directions analyses. When you want to get from A to B and you want to get driving directions, among other things, this is the module that you make use of. So I go ahead and sign in. And one of the things that you do when you're working with a network module is create a network layers. So here I want to find service area. The problem I'm trying to solve is, imagine you are all owners of a mattress store. And people want to come and buy a mattress from you. And when they want to come, they have to buy a mattress. They need to at least have a truck. So they need to drive and come and get a truck. How long will you guys drive to buy a new mattress? 30 minutes? Maximum, right? I wouldn't go more than 40, 50 minutes, 60 minutes to get it, to buy.
Unless it's a sleep number mattress, maybe I will.
Oh, you will.
Just kidding.
I generally have no problem sleeping, so I'm okay with whatever mattress I'm able to get my hands on. So that defines the people that are willing to get to your stores. That's the GIS problem you're trying to solve, right? And you can use this module to solve that. And we're going to just take a quick look at that. So we have just imported the service area layer. I'm creating a service area layer object. Let's imagine that Palm Springs Convention Center is where we have our mattress store located. Let's draw the convention center on the map. Now what I want to do is, you can compute the service area for various modes of transportation. Walking time, rural driving time, driving distance, and so on, trucking time. So because we are mattress store people, we are interested in trucking time. But you might as well change it to walking time and you'll get dynamically different results. What is important here is the service area we are computing is not based on Euclidean distance. It's not stone throw distance. It's not made on a buffer. It is actually it's actually produced based on traffic information, driving distance, posted speed limits, etc. on the street network. So the result you're going to get back is going to be a really weird shaped polygon that you're going to get back. So let's use trucking mode as our mode of transportation, and let us solve a service area. The Palm Springs geocoded result is going to be the center point around which the service area is going to be drawn. The breaks is 5 minute, 10 minute, 15 minutes intervals in which I want those service area to be generated. And the direction is direction from facility. So let's, it should, in our example, it should be away from facility where people will draw towards the center. But what this string really means here is that if you were to see how far you can get from Palm Springs Convention Center outwards for 15, 10, and 5 minute intervals, let's compute the service area in that perspective, and we could go ahead and draw it on our map. I'm just composing a feature set out of that, giving it a symbology, and looping through the result, I'm going to draw it back on my map. So here you will see in 5 minute interval, that's the distance it covers. So these are the people that can get to your store in 5 minutes. These are the people that can get to in 10 minutes and 15 minutes and so on. So another interesting thing is here I didn't specify the time of the day to be used in this computation. So you could very well specify at different times of the day, put it through a loop and start animating that. So if you go back to our documentation page, we have an example that shows with LAX, notoriously known for bad traffic as a point, and for different times of the day, how the service area changes. How far can you get in 60 minutes was something that is really drastic with time of the day, how much you can get to. So we just saw service area. But even before service area, something that we all would need is driving directions from point A to point B, and how we can use that, how we can use a really strong, powerful directions API in Python of ArcGIS and solve that problem. So here we are creating a route layer as opposed to a service area layer that we created earlier. And I want to geocode directions from LAX and Palm Springs Convention Center. How many of you are flying out from LAX? I'm so sorry. Well, I'm assuming the rest of you all are flying out from Palm Springs Airport, I guess. Okay. So we could very well change it to Palm Springs Airport, Palm Springs, but it wouldn't be as thrilling as computing and driving directions to LAX Airport. So we could do that, and what we could do is call the solve method on the route service, give our stops that we just geocoded, and we say, I need routes as a results back. I need the stops, driving directions that I can print out and take it with me, and a few other options. Now let's compose a map of Los Angeles. I can draw my stops, and I just drew my driving direction in red. So that just gives you driving directions from point A to point B using the ArcGIS driving API, and that you just control all of it with Python API. So that was a quick tour of the network module. Back to you,
Rohit. And that was a quick tour of the Python API as well. You have completed a lot of modules, and you're now all certified advanced Python API developers. We've got a lot of exciting things coming. That's an aggressive schedule. I hope I'm showing it to you, so we have some pressure on getting these stuff into this API this year. And now we are open for questions, and please do submit your feedback. Yes.
The data that you're working on here is stored in some probably in geodatabases and shape files and all that stuff, right?
The data that we have.
The data you're actually accessing.
Yes. So the question is that the data that we are working on, where is it stored? Is it coming from a geodatabase or a shapefile? We are working with the Web GIS, and we are working primarily with layers that have been published to the Web GIS that were feature layers. They initially came from shapefiles or file geodatabases or an SDEs.
Yeah, that's what's a little confusing me. The terminology, because we know about feature classes and feature data sets, and a layer is sort of a representation in a map. Mm-hmm. And then you can query that to get subsets.
Right.
But so now you have a different terminology, and my head's trying to get around the relationship between feature layers and feature classes. So that's sort of a little bit concerning to me. The language gets complicated.
Okay.
I notice when you're talking to somebody, you're using the same words, but they mean different things, so you're not really communicating. So that the terminology is a little funny to me, but how that relates. It's not a big deal, but it's just a concern that I have.
Okay, so the question or the comment is that we are using the terminology of feature layer and feature layer collection, whereas you are coming from probably an ArcPy background where the terminology used is feature classes and feature data sets. Yes, I can understand that. We are using the Web GIS information model, and in the Web GIS information model,
that's not an ESRI thing, it's a broader scope.
No, that's the ArcGIS information model.
Okay.
And in that model, the way these feature classes are represented are as layers. You can add these layers to your map, and you can use these layers for your analysis. Feature class is not used in that tier. It's not an item in that model.
I think the step you're missing is the publishing part.
Yeah.
So you publish your feature class as a service.
Okay.
And the service has layers, and you use those layers
Okay.
in web maps or in direct access.
Yeah, I got it.
The publishing part.
Exactly.
Right, so
It's
you're not talking
accessing-
about how it's actually stored on the computer.
Yeah.
You're talking about the publication version
host it, then it's in the Web GIS.
Okay.
But the data is still in your database.
I
Or it's in the ArcGIS data store, it's wherever you
Okay.
want it to be.
Yeah, so I have to learn more about the publication part of it. Thank you.
Thank you. Yes.
How does licensing relate to this? I'm assuming that if we want to do this, we need to have a desktop license, for instance. Is that true?
So the question is, where does licensing come in? What license do you need? You're working with your Web GIS primarily, and your Web GIS could be ArcGIS Online or ArcGIS Enterprise, and you could also be working with web layers that others have shared or made public. The layers that others have shared and made public, you can access those because to share them and make them public, those guys have purchased the license and done it. If you're using ArcGIS Online, you could do certain things as an anonymous user. You can consume the public content, but you cannot do analysis on it. If you want to do analysis on it, you would need an account on ArcGIS Online. That would be your organizational account, and that consumes credits. And so that's a SaaS offering. That's a hosted offering, ArcGIS Online organization. You could also deploy your Web GIS within your enterprise, on your premises or in the cloud, and you manage it on your servers, in which case you've purchased a license for ArcGIS Enterprise. And you are, as a user, you are a named user in that organization. So your organization needs to purchase, I might get in trouble because I may not be using the right terminology, but the short answer is that your organization or your Web GIS provider has purchased ArcGIS Enterprise or has a license for ArcGIS Enterprise or an ArcGIS Online organization and created an account for you that you use.
Can I perform version functionality on this using API?
The question is, can I perform versioning?
Yeah, versioning.
Do you know?
So,
Changing, versioning, reconcile, posting, all those functionalities, can I perform through API?
So the question is, can I perform versioning with this API, changing versions, reconcile? I think there is, I don't know, there is support for replicas, checking out data, updating it, and checking it back in. The sync and replica workflow, that is, it's in the REST API, it's in the Python API too.
That
Yeah.
would be ArcGIS. If you wanted to do post and reconcile, that would be ArcGIS, just straight up ArcGIS.
Okay, so yeah, again, thank you. The REST API doesn't expose that functionality, right? It doesn't have.
API works with the feature layer, create replica and synchronize replicas.
Yeah.
That's the only level that's available. That's not GeoAnalytics application that's available to the REST API.
So that's Shreyas Shinde, the architect of ArcGIS Enterprise.
I work on the application. So blame it on me.
Yes, please.
Is there a way to, using the Python API to provide that user input like you did with the password for other things, such as prompt the user for username, or basically do like arguments, so that when the user would fire off a cell and ask for username, password, etc.
Yes.
Oh, yeah.
So the question is, can you interactively ask the user for his username or password and use that? Yes, and other things. We'll just use the standard Python input function, which queries the user for those things, and you could do it that way. And if you don't pass in a password, the GIS constructor prompts you for that.
yeah. Or you can also use get pass if you want to, hide the inputs.
My thought was, I want to build, we have a series of Python audits that we wrote and eventually rewrote into the Python API. I want to give it to somebody else, and rather than have them go in and play with the
Yeah.
Python, I want them to just username, password, organization, go.
Oh yeah, you could use standard command line arguments,
Okay.
and you could receive it that way too.
You had a
The-
question?
Okay.
Sorry.
Oh, the other one also might be of interest to you is the concept of profiles.
Yeah.
So that way, users can store GIS credentials securely in their OS level credential store, and we can pick it up from there. So if everyone in your organization creates their credentials with arg_name_Python API credentials or something like that, then the same script can just run on each one's computer and pick up their credentials up. So that's another thing to.
And we also support Windows authentication, integrated Windows authentication. So it'll pick up the user's logged in credentials, and they don't need to provide their username and password if your organization or your Web GIS supports that.
Yeah. Another pattern is if everyone in your organization, everyone uses ArcGIS Pro, you can ask them all to sign in with ArcGIS Pro, and if you can use Python API installs with ArcGIS Pro, so your scripts can run out of that and pick up the credentials from whatever portal ArcGIS Pro is connected to. That's another pattern to solve that problem. Yeah.
One of the items you were querying was the layer, and it was bringing back the layer name and views and stuff like that. Is it so you can query the number of views? Can you query when those views were? So you can just query how many times it was viewed over the past week or something like that?
So the question is how many times a layer was viewed. That information is available on the item. So when it was, the number of views, the average rating of that item, some of that information is part of the Web GIS information model, and it's available on an item. And when I queried that item, you would see that it would show this one had two views and 0 comments. So, and it's also available on that item. So if I could say item.num views and get it, or number of comments.
Does that tell you when the views were? I mean, was it today or yesterday?
I don't know.
The views are on the items, not on the feature layer.
Yeah.
So if the feature layer was itself accessed, to a variety of applications many times, you wouldn't get those counts getting updated there. Here, the view count represents how many times the item was viewed inside the Web GIS as those objects and search queries that were used.
Yes. And to answer your question, that you are also interested in knowing when people viewed your layer, right? Is that the question? So the when you're an administrator, you can get that information from your servers, which has a reporting functionality, the metering functionality in it, that you might have seen in ArcGIS Manager. You can see the graph of the usage over time. You can get that through the API. So you'll know how many views happened in the last week. Mm-hmm. You could create reports like that and query them. And another way to do that is if you want fine-grained control, you can set the logging level, and you can also access your logs so you'll know when the access is coming. Okay, any other questions? Right, thank you so much for staying back.